Good day. The South African Mathematics Foundation, whose website is www.samf.ac.za, administers several competitions, mathematics competitions, throughout South Africa. And one of them is the South African Mathematics Olympiad, which consists of 3 rounds for juniors and seniors. So we are in the process of unpacking the solutions to all these competitions, as well as the team competitions that the foundation administers. Today, we are going to look at the senior round 2 paper that was set in 2023. Okay, we are going to do the program envisages solving all the problems from 2023, 2024, and 2025. So let's go straight to the problem in question. Okay, the very first question. Okay, this is the senior round 2, as I said, 2024, not 2023. My apologies. Okay, so here we have 2 equations and 2 unknowns. Normally, we would take the A's and B's and put them on one side and the number on the other side, and then try to eliminate one of them. But in this case here, you can do it very quickly because you already have B in terms of A. So, so all we have to do is to substitute for B in the first equation. You have 3A equals 55 minus 2B. Now, in place of B, you can write 10 plus 2A. So the B's are replaced entirely with A's, and you have one equation with one unknown, and that we can solve. Okay, so 3A, bring it to the other side. You have 7A is equal to 35. A equals 5. And B is equal to 10 plus 2A. We got B in terms of A. So all we have to do is to substitute A equals 5 into this, and 10 plus 10 is 20. So the question is not to find A and B, but to find A plus B. Always answer the question. All right, so that's a straightforward problem. We always give the solutions also in typed form. And I'll quickly look at my solutions to check to see whether my calculation is right. So we see here that A plus B is indeed 25. Okay, the next question, here you've got 5 fractions. And these fractions are very similar, except that each one is obtained by increasing the numerator and denominator simultaneously by 1, as you can see. Right? So you've got 5 fractions. And the question is, what is the numerator of the largest fraction below? Okay, so we need to find which of these is the largest. They're all approximately the same because they're just a slight adjustment to get to the next one. So how are we going to do that? And these are big numbers. You're not allowed to use the calculators to find out which one is the largest. All right, so let's try to use the mathematics. So what does the mathematics say? Instead of using all these symbols, I will just take any one of them. Let's call it A over B. So A could be 500 and B could be 1,000, or A could be 501 and B could be this. And I need to compare it with the next one. And the next one is A plus 1 over b plus 1. So I'm going to compare this with any one of these with the next one. And I want to see which is larger. Now, one of the ways of doing that is to subtract the two. And if the difference between the two is negative, then you can say that if it's positive, let's do that, that's the easy one. It means that this is larger than that to give a positive difference. And if it's negative, then this is smaller than that. So let's do that, because now this becomes just a calculation involving two fractions. The common denominator is b into b plus 1. The numerator is a into b plus 1 minus b into a plus 1. And when you simplify that, you will see in the top, if you get ab minus ab occurring, ab plus a minus ab minus b. And the ab, you can cancel it. Now a and b are the numerators and denominators respectively. And you see that the numerator is smaller than the denominator in each one of these cases. So a minus b is negative. The numerator is negative. And the denominator is a positive number. And if you multiply these two things together, you get a positive. So this is negative over positive. So that is negative. So that tells you that a over b, and if you take it to the other side, it's less than a plus 1 over b plus 1. Right. So that means we can go straight to this, and we can say this is a over b, and this is a plus 1 over b plus 1. This is smaller, that is smaller, that is smaller, that is smaller. So you can say the largest one is this one. And the question is, what is the numerator of the largest? So that is the numerator. So the answer is 54. Okay, so this is a good example of where you can use simple mathematics to solve a problem without a calculator. Okay, let's get to the solution that I had written earlier. Oh, there it is. Actually, the answer is wrong. I didn't answer the question. The question was find the numerator, not the fraction. All right. So don't do what I do. Please make sure you answer the question. Okay, the next question is this one. It shows you a circle, and it says that the area of the shaded region is 15% of the area of the whole circle. And the question is, what is the value of x? X is the angle in between. Yeah, at the center. So, look, this is a problem on ratios. You know the shaded area is 15% of the whole area, and you want to know what is the angle at the center. We call this the angle at the center. Okay, so let me take another example. You see, in one case I know, well, in a couple of cases, but this particular case, namely, if that angle was 90 degrees, if this angle was actually 90 degrees, all right, then the area is a quarter, which is 25%. So we know that 25%, quarter of circle of the area is 25%. So we know that 25% corresponds to 90 degrees, right? So all we have to do is to find out what is 15%. So that is a question of proportion. Okay, so you have 15 over 25 times 90, and 5 goes into this 3 times. With fractions, I like to cancel. I don't multiply. Cancel as much as I can. 5 goes into this 3 times, 5 goes into this 5 times, 5 goes into this 18 times. So in the end, you got 3 times 18, and that is 54 degrees. So x is 54 degrees. Okay, so that takes care of question 3. Let's move on to the solution first to just check to see whether I had, there you can see it's 54 degrees. All right, let's just go on to question 4. Question 4 says, what is the smallest possible value of a over b plus b over a if a and b are positive integers? Now, that's interesting. You don't know what a and b are, but the question is, what is the smallest possible value it's got? So you can try various values, positive integers, say 5 over 11 plus 11 over 5. It's a over b plus b over a. So you switch it around. And if you work this thing out, you get 25 plus 121, which is 146 over 55. And that is 55 goes into this 2 times 2 comma something, whatever, around 2,6. Okay, so this, if you put these numbers, you get 2,6. And if you try various other numbers and see what it is, you will see that in all cases, you'll get a number which is larger than 2. See? So how do you do this now? Because you can substitute any numbers you feel like. Okay, now here's the mathematics again. Mathematics is so powerful. You can solve a lot of nice problems using algebra. Let's simplify this and see what you get. You get the denominator is AB, and the numerator is A squared plus B squared. All right. Now, you can see that A squared plus B squared is positive, but you don't know what the smallest value of this is. You need to look for the smallest value. And that there is a trick. Well, normally, whenever you have this kind of a thing, you take the square. See, A squared plus B squared is part of a square. It could be A plus B all squared or A minus B all squared. I'm going to put A minus B all squared because this kind of strategy is quite well known. Take A minus B all squared. Now, when you expand this, what do you get? So essentially what I'm doing is I'm adding minus 2AB plus 2AB. I'm adding 0, so it's not making any difference. But this part here is A minus B all squared. A squared minus 2AB plus B squared over 2AB. I'm sorry, plus 2AB. And that, if you write it like that now, then what happens? If you simplify this, I'll just separate these two fractions. Plus 2AB over B over AB. And you can see if I simplify this, I got a single denominator. It's exactly the same as that. But this part here is 2, you see. So you have 2 plus a minus b all squared over ab. Now you can see that this part here is positive because the square number is always positive. A and b are positive. So this numerator is positive, can be 0 if a equals b. So this part here can be 0, but it's certainly greater or equal to 0. So this whole thing is certainly greater or equal to 2, because 2 plus a positive number. So now that means that that's regardless of what a and b are. Interesting that a and b have disappeared somehow, and this will always be greater or equal to 2. It's actually equal to 2 if a is equal to b, right? Because then this is 0. But we could have seen that right here. If a equals b, then this is 1, and this is also 1. So 1 plus 1 is 2. All right. So, but in general, it's always greater or equal to 2. So the 2 can be achieved because if a equals b, you can make it equal to 2, but otherwise it's greater than 2. So 2 is the answer. It's the smallest possible value. All right, so now you can see the questions become a little bit demanding, but you got a new strategy to solve problems like this. Actually, while I'm here, I should say the following. Let me just clear this. This is a very, very important inequality. It's used very often. And it's the following. It's a plus b all squared is equal to a squared plus 2ab plus b squared. But if you squeeze in a minus 2ab here, but you have to make an adjustment. You have to add 4ab to make this equal. Then you get this is a minus b all squared plus 4ab. Now this is a very useful, what you call an identity. It's true for all values of a and b. See? And similarly, a minus b all squared. This is even more useful, is a plus b all squared. No. The one that I'm looking for is this one. The same thing that we have used just now. And that is a squared plus b squared is equal to a minus b all squared plus 2ab. But the important thing is that this is greater or equal to 2ab. Always. Right? That the sum of squares of two numbers is greater or equal to 2 times their product. Right? With equality, they can be equal only when this part is 0, when a equals b. See? All right, so these equations, always have them at the back of your mind in problems like this, because sometimes one of them can be used to solve the problem which is at hand. Okay, let's look at the next problem. We've gone on to question 5 now. Okay, so you can see I've written this thing out completely, so you can have a look at that, freeze it freeze that pain and study it in case you lost out, you forgot, or you didn't follow anything that I said earlier on. Here, you've got a geometry problem. You got a triangle. What kind of a triangle have you got? You got an isosceles triangle. Two sides are equal. And there, of course, if you're in an isosceles triangle, you know that the angles opposite the equal sides are equal. So you've got two angles of a triangle are equal if and only if two sides of the triangle are equal. Such triangles are called isosceles triangles. Now, here you got an angle x here, but it's also given that this part here is, these two are equal. So you got an isosceles triangle here, kind of sleeping. We don't know what x is, but let's call this y. Let's call that angle y. The reason why I call it y is because these two are equal here. So this is y. Yeah, so these two are equal, so therefore these angles are equal. The large triangle is isosceles, but the right-hand triangle is also isosceles. So if this is y, this is y also. Okay. So what happens here is that x is y plus 30 because it's the exterior angle of a triangle. One of the first theorems that you learn in geometry is what I call the flag theorem. If you have a flag, essentially you have that you got a triangle with one of the sides extended. Then the what we call the exterior angle, this one is exterior, is equal to the sum of the two interior opposite angles. See, this angle is equal to that plus that. The reason for that is that both of them are equal to 180 minus, well, maybe you can't see this dot here. 180 minus dot is that one, and it's also the sum of these two. The sum of three angles of a triangle is 180. So this is equal to that plus that. So here you got that x is equal to y plus 30. So there's your flag here. There's it here like that. This is extended. This exterior angle is x. It's equal to the sum of the two interior opposite angles. But you also have that x plus 2y, because these angles are angles of a triangle. X plus 2y is 180 degrees. Okay. So then you can put x equal to y plus 30, and eventually I think you get y is equal to 75. No, x is y plus 30. So y is 50 and x is 80. When you solve this, you'll get x is y equals 50 and x equals 80 degrees. So the problem is x is 80 degrees. I think I could have done this thing much faster if I did the following. Let me clear all the diagrams. Okay, so I should have gone straight to this. You see, this is x here. So this is x minus 30. Because this is equal to that plus that. And this is still x minus 30. I don't have to use a y. So this is x minus 30, and these two are equal. So you have x minus 30 here also. See? So these two are equal. Now you got the three angles of a triangle. They all add up to they all add up to 180 degrees. So you got 3x. If you add these three, x occurs 3 times 3x minus 60 is 180. Therefore, 3x is 240 and x is 80 degrees. Right, that is very much faster. All right, so let's now go on to the next problem. Okay, let me just check to see. Okay, here yeah, I did it the same way as I did it the first time. All right, but I just told you that there is a faster way of doing this. Okay, what is the sum of the digits of this number here? Oops, this is a huge, huge number. If this is calculated, now if you write this number out, you probably will die of old age because this thing has got thousands of digits. All right, but let's just see, it's got 2 and 5, and 2 and 5 are nice numbers because when you multiply them, you get 10. So what is, if you add up all this, what is the sum of the digits? Well, let's do some algebra on this. 5 to the power of 2026. Now let me make both the exponents the same. I'm sure that'll help. Oh, it's 2024. 5 to the power of, make this 2024. But then this is 5 to the power of 2026. Must always respect the equal sign. Right? Very often people don't even write the equal sign, which is criminal. For me, it's just criminal. Because the equal sign is the verb of a sentence. This side is equal to that side. You can't remove a verb from a sentence. Right? So you respect the equal sign. So if you multiply these two, you'll get that. Now, this is nice because you got the same exponent. So you get 2 times 5 raised to that. I'm using the fact that AB to the power of n equals A to the n times B to the n. This is one of the laws of indices. Might not be stated like that. Okay, because the three laws, but I regard this as also a law, a fourth law. 2 times 5 is, okay, still 5 squared still comes down, and 2 times 5 is 10. So you know exactly what this number is. So it's 25, 10 to the power of 2024 is the number with 2024 zeros behind it. So this is 25 with lots of zeros, and they don't add to the sum of the digits. You see? So this is equal to 25000, only zeros. So the sum of the digits is what you're looking for, is 7, because it's 2 plus 5. The others don't make any contribution to the sum. Okay, so let's check to see whether we can go on to the next problem. Okay, you can see that the sum of the digits is indeed 7. We go on to question 7. Oh, question 7 has got lots of square roots and things like that, yeah? Okay. This 4 here is actually inside. It's the, yeah, that is 4. Now, how do we handle this thing? You got 4 different square roots here. Okay, so you'll have to you'll have to work it out from the inside and build it up to the outside. The inside one is cube root of 8. So this part here, cube root of 8 is 2 times 2 times 2. The cube root of that is 2. So this thing here is 2. Now you got 2 plus 2. 2 plus 2 is 4. So the square root of 4 is 2. So this is square root of 2 plus 2, which is square root of 4. Now you got 14 plus 2. Oh, let's put a 4 here. The square root of 4 is 2. So the square root of 14 plus 4 is square root of the fourth root of 16. Now 16 is 2 to the power of 4. It's 2 times 2 times 2 times 2. So this is 25 plus 2, which is 27. And you're asked to work out it's 27 to the power of 4. So this is the cube root. I told you in the beginning that this is raised here, 27 to the power of 4. Okay, now how do you do that? This is 27 to the power of 4, all raised to the power of 1/3. And the cube root means it's raised to the power of 1/3. 27 by itself is 3. So this is 3 cubed. So you got 3 cubed to the power of 4, right? Which is 3 to the power of 12. And this is 3 times 3 times 3. And that group is multiplied by itself 4 times. So you'll have 12 fours. And 3 to the power of, this is the third law of indices kicks in. And 12 times 1/3, you multiply the indices, is 4. So you get 3 to the power of 4, which is 81. You see, all you could have, yeah. So it turns out that you can take the cube root first and then raise it to the power of 4, as we have seen here. But yeah, according to the way it's written, it's raised to the power of 4, and then you work out the cube root. Okay, so that takes care of problem number 7. And we can go on to problem number 8. Right, so you can see the answer here is 81, which is the answer that I got. Go on to question 8. Okay, I'm not going to read all this. I'll just tell you what it is. Okay, so this problem says the following. It says that you got Martians. People like to just dramatize Martians. It doesn't really matter what they are. Let me just draw my oh. I want to draw my circle. Okay, so you got all these guys who are standing around in a circle, and they are numbered. 1, 2, 3, 4. There are 24 of them, to be precise. So you got one standing somewhere. They're all next to each other. 2, 3. So these are the 24 people. And the 24th person is standing next to one. So what these guys do is they shout out, they start counting. right? They count. This fellow counts 1, 2, 3, 4, and they keep counting. This guy counts 24, but this fellow counts 25. He doesn't count 1. He continues counting. So he counts 25, and then 26, 27, 28, up to, right, 25. Now it's 25 plus 24. When it comes to this guy here, will say 48, and then this fellow will say 49. So another 24. So the one counts, the first fellow counts 1, you'll say 25, you'll say 49 and 73. Like that, this guy will say 26, and then you add another 24 to it to get all the numbers he counts, and so on. And the question is, if I just take you to that question, it says, what is the number of the Martian who calls the number out 2024? Who calls out 2024? That is really the question. So I'd like to, I don't know who calls out 2 to the 24. Okay, but let's see what 1 calls out. And we'll try to get as close to 2024 as possible. So 1 calls out, we saw 1, 25, 49, and so on. Now, this is an arithmetic progression or arithmetic sequence. Let's write AS for that. And the first term is A, right? We normally use the symbol A for the first term. You would have done arithmetic sequences, so I'm not going to dwell on that. And the common difference is 24 because we keep adding 24. So D is 24. And we want to know who calls out 2024. So we want to know what the nth number in the sequence is. What is Tn? Now the formula for the nth term of an arithmetic sequence is A plus n minus 1D, right? And A is 1, n minus 1 times 24, because D is 24. Okay, I took up too much of space here. All right, now when you simplify this, let's just I'll just create a little bit of space here. Or maybe I'd better take all this out. I really don't need all this stuff now. So the nth term is that I just want to simplify that nth term. 24n minus 24. And then that is 24n minus 23. Right. 1 minus 24 is minus 23. Now, I want to get as close to 2024 as possible because I want to see what, this is what the first person calls out. I want to see what the first person calls out closest to 2024. So what is the largest value of n? Right. Now, you see here that this makes 24n, bring the 23 to the other side, and you have 2047. And so n is less than. Now, when you divide this by n, 24, okay, so here you have to, this is 85 and 7 over 24. Okay, you have to do some long division here. And get to something like that, because I know that 24 times 85 is 2040. Okay, but the largest value of n is, if n equals 85, n is a whole number. So we are looking at the terms of the sequence here: 1, 25, 49. So at 85, when n is equal to 85, you have 2000 Tn is equal to 24 times 85 minus 23, right? N is equal to 85, and this is 2040 minus, so this is 2017, right? So what's the point about this is that 2017 is one of the numbers that one shouts out. See? So he also counts, I can put this as one of the numbers he calls out, 2017. So if you go now, you want to know who shouts out 2024, you have to go and look at that circle that I had drawn originally, and I took that out because I needed space to do all these calculations. So you got 2017 is what one shouts out. So one shouts out 2017. Now, the ones after him shout out the numbers like this: 2018, 2019. I want to get to 2024. Right, so this is 1, 2, 3, 4, 5, 6, 7, 8. So the eighth person shouts out 2024. And that is the question. Which person shouts out 2024? The answer is the eighth person, because we figured out what one shouts out, and we've got to very close to 2024 so we can answer the question. All right, so that is the answer to this question. And if you, so there it is, the eighth Martian calls out 2024. If you didn't understand my solution, you can have a look at this, and all the time in the world to have a look at that. So let's look at question 9 now. Question 9 says, what is the largest value of x? So that 2 to the power of x divides exactly, they shouldn't say value, they should say integer. Because x is a real number. There's no answer to this. Okay, so now you got a product of a lot of things here. So you want to know, so essentially what we need to do is to factorize this and look at the power of 2 in this, so that the largest value of x means that you take out all the 2's and the remaining factor does not have a 2 in it, which means it must be an odd number. So let's rewrite this as 1 times 2 times 3 times 4. I'm going to go as far as I possibly can, times 7 times 8 times 9 times 10, and so on. Okay. Now, what are the multiples of 2 here? So you got 2, 4, 6, 8, up to 18. Now, how many 2's are there? If you take 2 times Right? The twos are here, not in the odd numbers. Right? So just isolate only the even parts here. And you got 9 twos here. So this 2 to the power of 9. Right? But when you take out those twos, you'll see that this has got 1 2 here, but this has got 2 twos. So the multiples of 4 these multiples of 4, you can take out the twos here, and there are 4 twos which you can take out from these. So when you take out the twos from here, see, I've already counted the first 2. So 4 is 2 times 2. Now this is 2 times 2 times 2. So 8 and 16 contribute another 2. 8 and 16. All right. So multiple of 4 is 4, 8, 12, 16. That contributes another 4. And the 8 and 16 itself has got 4 twos in it. So we must include the 16 as well. Right. You see, 4 is 2 squared, 8 is 2 cubed, 12 is 2 squared times 3, 16 is 2 to the power of 4. Right? So you see, these don't contribute only 1. So you got, so this is actually equal to 2 to the power of 16, 13 times an odd number. You can remove all the 2's and no 2's are left, and therefore this is the highest power is 16. All right, okay, I didn't do this very well, but if you substitute for 8 and so on, you will see that you'll have to add all these indices. The other ones like 2 and 6 contribute just 1, 2. So I counted all that right in the beginning. The way I did this was counted which ones contribute only 1, 2. That's 9. Which one contributes at least 2 twos? There are 4 of them. Which contributes 3? There are 2 of them. And which contributes 4? There's 1 of them. Right. So that's how I got this power. All right. So that takes care of that problem. Just want to check to see. Yeah, so the answer is 16, as you can see. All right, so we go on to the next question 10. Question 10. You see, this paper consists of 25 questions. So it takes a long time to work out each one of them. Question 10, 10 people stand in a row. Right? The first person goes to the back of the row. Right? And the next person leaves the row, so he goes away. So that the person who was third in the row is now first in the row. So now the first person in the row goes to the back of the row, and the next person leaves the row. So this process is repeated until only one person remains, because people they keep leaving from the 10. So 9 people will leave somewhere along the line, and that one person. And the question is, what was the original position in the row of the only remaining person? All right, now this is kind of a tricky problem. And I'm going to just sort of physically see what's going on here. So let's call these people 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the 10 people. And I want to know which number survives and what was the position of the person who remains after all this is done. So what do you mean by saying all this is done? The one goes to the end. So you have 2, 3, 4, 5, 6, 7, 8, 9, 10, and the one goes to the end. And then the first guy is removed. So the first guy at that stage is 2, and we remove him. All right. Now the same process is repeated. The 3 now goes to the end. So you have 4, 5, 6, 7, 8, 9, 10. The 1 is there, and 3 goes to the end, and the first guy is removed. So we remove this fellow. Right. So you can try, you can do the rest, and you will see in the end you land with all the even guys, all the even people are removed, and you eventually have that the ninth person is still standing there. Well, not eventually. You come to this situation here, right? And then no, I'm sorry. It's the other way around. The 1, 3 still remains in that order. The ninth person goes to the end. He survives. So you have 1, 3, 5, 7, 9. And then if you keep doing this, you'll see that the last survivor is 5. Okay, so there's not much mathematics here. You just have to follow this through. You can argue that all the even people go away and you're left with these, so you don't have to write all this. And then from here, you work only with this 5 which remain after those 5 even people are removed, and you'll end up with 5. Okay, so if we clear all the drawings and we go to this, here I've got the entire uh, okay, so I didn't skip any steps, so you can check to see. So the next question, question 11, it says the following. In the set of perpendicular line segments shown on the right, AB is equal to 10. So this is AB. So this is 10 units. And every other segment is 1 unit shorter than the previous one. So this next segment is 9. The next segment is 8. So you're climbing up A, B, C, D, E, F, and so on. And this is 7, 6, 5, 4, 3, 2, 1. Okay. Now, the question is, what is the distance? What is the length of the line segment AK from here to there? All right. Now, before I do that, I can see it's a kind of a tilted line, and all these lines are going horizontal and vertical. So there's evidently Pythagoras is kicking in here somewhere. And I just want to observe that AK is the hypotenuse of this triangle here. So we have to calculate this distance. This distance from here to here. In other words, the horizontal distance from A to K. That's the horizontal distance from A to K. And you also have to calculate the vertical distance from A to K. So let's work out the horizontal distance and the vertical distance. I'm going to remove this diagram, these red lines for the time being. So I need to know the horizontal distance from A to K. Now, here's something. You see, if you look at the distance, the horizontal distance from one parallel line to the other, watch. This distance is the same as that one minus that one. This is 9 and this is 7. So therefore, this distance here is 2. Now, the point is the distance between any two parallel lines next to each other is always 2. Now, what's the reason for that? The reason for that is when you go, you have to go, you decrease by 1 along the horizontal. Nothing is decreased when you come down here, but you decrease by another 1 when you come back to where you started, to this line here, to this line. So you decrease by 1, and because there are two parallel lines, you decrease by another 1. So you'll have the original length is decreased by, the distance between them will be 2. And you can argue this thing right throughout like that. So therefore, we can, if you go to this, to what I wanted to calculate, and so this thing here is, it's 2 here plus 2 here, but remember this part here is just 1. So this is 2 plus 2 plus 1, because the distance from here to here is just 1. All right. So this horizontal distance is 5, but down this way you've got a 2 here, you've got another 2 here, you've got another 2 here. So this vertical line here is 2 plus 2 plus 2. Right? Because from here to here is 2, from here to here is 2, from there to there it's 2, so it's 6. So therefore you've got AK squared by Pythagoras is 5 squared plus 6 squared. 25 plus 36 is 41. All right. So it's a matter of trying to see what we are doing here, how to calculate AK. You complete this right angle triangle, and you see, I really need to know what this horizontal distance is. And then you argue it out, and you will see that you can. Otherwise, it can be quite complicated when you do this. All right. I didn't do it like that, and I did something very much more complicated. If you go to my solution, you'll see I got coordinates here. I took this as coordinates here, and I calculate all these various coordinates for each point. by coordinates, I mean I chose my x and y axis somewhere. To be precise, this is my x-axis, and that is what my y-axis. And then I calculate the coordinates of all these points. This goes up 10 units and decreases by 1. So this is 9, 10. And then you do the same thing at each of those places. And eventually you'll end up, the coordinates here are 5 and 6. So the distance from here to here, you can calculate by completing the right angle triangle, as we did before, and you get square 41 is a square. You're asked to calculate AK squared, not AK. So that is, oh, it's 61. 36 plus 25. Oh, I don't know how to add. It's 25 plus 36 is 61, not 41. 4 squared plus 5 squared is 41. Okay, so let's get on to the next problem. Problem number 12. It says in the table, the product of consecutive integers represented by these letters are given. So if you study that table, let me just make this a little bit bigger. X, Y, and 9. So it says here that the product of the positive integers represented by the letters in each row are given. For example, X times Y equals 9. X times Z is equal to 45. Y times W is 16, and so on. So what you've got here is that 9, let me just write down the 9 here, and 80, and here you get 45 and 16. So you got a factorization of 16 along the vertical. This is a factorization of 45. And here you got a factorization of 9. Here you got a factorization of 80. All right. So you have to fill in, you want to know what is XW. So you have to fill in these blanks. All right, now the crucial thing that you have to observe here is that any one particular guy is a factor of 9, because this time something is 9, and it's also a factor of 45. So these numbers here are common factors. It's a common factor of 9 and 45. Okay, so it could be 9 or 3 or 1 and so on. So there are lots of possibilities there. So like that, now if you take any one, any two, you'll see each one, there are lots of possibilities. But there is one case where there's only one answer. And that is, if you look at it carefully, before listening to me, you can try to think. And the answer is here. Because this number is a factor of 9, and it's also a factor of 16. Say 9 and 16, I've got no common factors, apart from 1, of course. Right? Such numbers are called co-prime numbers, pairs of numbers which have got no common factors apart from 1. So this number is forced to be 1 now, you see. So now after that, you can fill in the rest. This is 1, this has to be 9, 1 times 9, this has to be 5, 5 times 16, or if you want 1 times 16. So your XW, X is 9, W is 16. This is what you need to calculate. XW, so XW is 16 times 9 or 9 times 16, and that is 144. All right, so that takes care of that. Let's just see. Okay, the drawings and get on to the. Oh, okay, so there you can see the answer is 144.